Alright, page 2. Just have a couple problems where you're going to be using these fractional exponents to help you get your solution. So on the first one, love these problems because it's always nice, hopeful, wishful thinking we get these values or these dollar amounts from our parents. So you read number 13, it says your parents gave you $5,000 for your birthday. Wow, what a birthday present. And told you, however, that you had to put it in the bank and can only take it out when it has doubled in value. You're hoping to do this in 10 years. What is the annual percentage rate, or what annual percentage rate is necessary for you to double your money in 10 years? So 5,000 doubles, that means it's going to be now worth $10,000. So the formula we're going to use for this, since it's not compounding, is this A times P times 1 plus R over N to the NT power. What's nice about this one is it's not compounding monthly or weekly or quarterly, so our n ends up being 1. So our amount that we want is 10,000. The amount we're putting in is 5,000. 1 plus, really we're just finding r since n is 1, and our time is 10 years. So now we just need to solve for r, so we need to do our inverse operations. So again, reverse PEMDAS, divide both sides by 5,000. So when I do that, I get 2 equals 1 plus r to the 10th power. Now some of you will want to subtract 1, but you can't do that because it's being raised to the 10th power along with this plus r. So what you have to do is you got to get rid of it by taking everything to the 1/10th power. So those will cross out. So you'll have 1 plus r, and then we got to get that value. So we're going to take 2, raise it to the, in parentheses, 1 divided by 10 power, close parentheses. That will tell me my value here. So I'm going to round that to 3 decimal places. So I have 1.072. I can subtract 1. Lo and behold, I have my rate, 0.072. Change that to a decimal, so my rate is going to be about 7.2% interest. Now on B, it says, what annual percentage rate is necessary for you to triple your money in 10 years? So in this case, since we're trying to triple, we're now talking about 15,000. So as we do this problem, the only thing that changes, 10,000 now becomes 15,000. So everything else is the same. So when I divide by 5,000, probably notice that instead of it being 2, this is now 3. We do the same process, raise it to the 1/10th, raise it to the 1/10th power, crosses out, so 1 plus r is going to equal, calculator time, 3 raised to the 1 divided by 10 power, close parentheses, 1.116. So you can see the interest rate is going to have to go up. Subtract the 1, r equals 0.116, which in turn implies that the interest rate needs to be about 11.6%. Alright, that takes care of number 13. Number 14, how about this? You won $100,000 in the lottery and want to put it away for retirement. Smart thinking. You're hoping to retire in 40 years, so you must have won this at an early age. What is the annual interest rate given the following, or what is the annual interest rate given the following situations? You want to have $1 million and the interest is compounded monthly. Ooh. So this is your A, your 100,000 is your P, there's your time. This one is monthly, so N equals 12. And again, we want R. So we're going to start by saying $1 million, wow, is equal to $100,000 times 1 plus R is what I'm looking for, divided by 12, raised to the number of months times the number of years. So 12 times 40 power. So now if I want to solve this, first thing I need to do is get rid of the 100,000. So I'm going to divide both sides by 100,000. So when I do so, I have 10 equals 1 plus r over 12 to the, if I do this 12 times 40, I'm just going to save myself a little energy there. And note that that's to the 480th power. Wow. So now we need to take it to the inverse. 1 over 480 power. 1 over 480 power. So I get 1 plus r over 12 is equal to, so on my calculator I'm going to take 10, raise it to the 1 divided by 480 power. So I'm going to get a pretty small decimal with the 1 there. So 1.0048 is what I'm going to note. 1.0048 ... So now I have to subtract the 1. Whoops, didn't mean to write the divide there, so I'll take that away. So subtract the 1. So now I have 0.0048 is equal to r over 12. So to undo division, I multiply both sides by 12. So r ends up equaling. So what I can actually do to get the exact answer on my calculator is take that answer, subtract 1, and then times it by 12. This will give me the exact interest rate, 0.0577. So 0.05, well, we'd round to 8. So we end up having an interest rate of about 5.8%. All right. On the last one, two things have changed. Now it's 2 million, and now it's weekly. So I'm going to change this to 2 million. Same setup though, just a few different numbers. 100,000. 1 plus r. Weekly is 52 weeks in a year. So I'm going 52 times 40. So now, on this one, if I divide by 100,000, I get 20 is equal to 1 plus r over 52 to the, if I multiply the 52 and 40, I get 2,080. So now what I want to do is take this to the 1 over 2,080 power. 1 over 2,080 power. Crosses out. And so now, on my calculator, I'm going to take a look at this. 20 raised to the 1 divided by 2,080 power. So we're going to get another number that's pretty darn small. 1.0044 ... So 1.00144 ... equals 1 plus r over 52. So now I'm going to continue to solve this. I'm going to move it up here a second. So subtract the 1, which you can also do in your calculator. 0.00144 ... equals r over 52. Then I'm going to multiply both sides by 52, and I'll have my r value. So r will equal, so my calculator, since I still have it here, I can subtract the 1, and then times it by the 52, and I get 0.075. So r would be about 7.5%. So if I can earn that 7.5% over the 40 years, I'm going to have $2 million. Wow, 100,000 to 2 million. How about that? All right, that ends your worksheet for today.